All right, so here's another problem, an example problem that related to our upcoming exam. And I need to correct something. I think I corrected it here, but that needs to be 10 to the 3. Okay. So we have a mass stiffness spring damper system, and the mass is equal to 10 kilograms. The stiffness is equal to 1,000 newtons per meter. So we're going to place a dashpot that is in parallel with the spring and choose a viscous damping value so that the resulting damped natural frequency is 9 radians per second. So here we go. 9 radians per second. This isn't too much different from, let's say, that. Well, it's different from that problem. It's probably closer to that problem than anything else, right? Probably a little close to that problem. No. Okay, so it depends on what you're looking for. So we determine that's the overshoot displacement. Okay, so it's not any. It's actually closer to the quiz problem, I think, because we were looking for C. I don't think I had done this one by that time, but maybe I was influenced by it. So first thing we can do, as with many problems, if you have the stiffness in the mass, we can find the natural frequency. So if we're talking about strategy for this exam, you definitely want to get to points that you can, but by finding the low-hanging fruit and getting the natural frequency, because you can find it here, not a bad idea. So this ends up being 10 radians per second. By taking the 1,000 divided by 10, ends up being 100 square root 10. All right. Then we also take the this equation here for the damped. Oops, not equal. Square root of 1 minus squiggle squared. So what we could do is we could find squiggle from this. A little bit of effort. Let's go in steps, because it is math, right? Omega d over omega n is going to equal to, but we can square it, right? It's going to be equal to 1 minus squiggle squared. I saw some people mess this up, so let's be careful. So that's going to be the same thing as squiggle equals the square root of 1 minus omega d omega n squared. Be careful here, because you're playing around a little bit. Like, we could make squiggle, this is my way of thinking, it might not help you. Over here makes that positive. This right here makes that negative. And then we take the square root of the squiggle, and we have this. So we have squiggle is equal to square root of 1 minus, and we don't want this to be negative on the inside, so you know that omega d is less than omega n. It's kind of always that way, but we have 9 over 10 squared, and we confirm that that's true. All right. So we have ourselves a 0.4359. Great. Cc 2m omega n. That's going to be the critical damping coefficient, 2 times our 10 kilograms times the 10 radians per second that we have, and we know that that falls into 200.0, and these are newton seconds per meter. So what we're left with is squiggle is equal to C over CC. Therefore, C is equal to squiggle times CC, or 0.4359 200. And I know we just did a problem like this. I don't know where the hell it is, but in this, maybe there's another example in class. I can't remember where it is, but boom, boom. That is the answer, and I think it matches with what I put into the other one right there. I don't think I made a mistake. So let's go to another example in a new video.